S1L27 is the quadratic formula, and the quadratic formula is just another method that we can use to solve quadratics. What's kind of cool about it is that you can use it to solve any quadratic equation regardless of how simple or how complex it is. Before we can get into what the quadratic formula is, I just want to review standard form. So standard form up in the upper left, it's either y equals or a equals depending on what type of equation or function you're dealing with, but the real kind of gist of standard form is the order of the terms. So it's ax squared plus bx plus c, and a, b, and c are referring to coefficients and constant terms. Those will actually be numbers in any equation that you're given. So a is always the coefficient of x squared, b is always the coefficient of x, and then c is always the constant term. And standard form just kind of orders those terms in order of highest exponent down to lowest. So you can see x squared, and then x to the first power, and then the constant term at the end. And then the quadratic formula over here, you can see it's kind of a daunting formula, but it's not that bad once you kind of get to practice with it. So it's x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, and then all over to a. So the a, b, and c in the quadratic formula are going to be the same a, b, and c from standard form. So you'll be given an equation either in standard form or you'll be asked to put it in standard form, and then you'll find a, b, and c from that before putting it into the quadratic formula to solve for x from that equation. Before we get into the actual examples, there's one more thing I want to talk about, and that's the discriminant. So over here, the discriminant, so the kind of formula for the discriminant is b squared minus 4 times a times c. And then that should look kind of familiar because it's inside the quadratic formula. It's the part that's inside the radical. So just the part inside the radical, b squared minus 4ac, is called the discriminant. And depending on what the value of the discriminant is, it can tell you how many solutions the equation will have. So if you have a positive discriminant, you're going to have 2 real solutions. If the discriminant is equal to 0, you'll have 1 real solution. And then if it's a negative number, you'll have no real solutions. And that's because it's the number inside the radical. So if I have a positive number inside the radical, say for example, if I have the square root of 4, that would give me solutions positive and negative 2. If I have a 0 inside the radical, that would give me just 0. There's not a positive and negative 0, it's just one version, so one solution. And then if I have a negative number inside the radical, say negative 16, that's going to be no real solution because I can't square a real number and get negative 16. So that's kind of why those different outcomes for the discriminant end up having those different quantities of solutions, I guess. But just something to kind of keep in mind if you are ever asked a problem that it asks you how many solutions there are, but you don't necessarily have to solve, then you can just use the discriminant. You don't have to use the entire quadratic formula. Okay, so example 1, put the equation in standard form and find a, b, and c. So standard form means everything is on one side of the equal sign, and we have kind of exponents over x in order from highest to lowest. So if there's not a y already in your equation, like some of the standard form formulas have, you don't have to put that in there. It just means that we're going to use the one that's equal to 0. So we just need to get 0 on one side of the equation. If there was a y there, you would just get y by itself on one side of the equation. Think of them as kind of a little bit interchangeable in this case. Okay, so 5x minus 7x squared plus 12 is equal to 6. So I'm going to prioritize getting everything on one side of the equal sign first. So I want to figure out a way to get rid of this 6 since it's, I don't know why that happened, but since 6 is positive, I'm going to go ahead and just subtract it over. And I want to line it up with any like terms that I have of it on the other side of the equal sign. So since it's a constant, I'm going to put it under the 12 since the 12 doesn't have a variable either. So I'll just copy down the 5x minus 7x squared, and then 12 minus 6 will be positive 6, and then it's equal to 6 minus 6 is 0. And you wouldn't just cross it off and leave nothing there. You would want to put the 0 there so we have something on that side of the equal sign. And then now I have to reorder it so that the x squared part comes first. So the x squared, that part has the 7x or the negative 7 in front of it. So I would reorder that term to the front. And then next has got to be my bx term. So I'm going to put that 5x 5x second. So since it's a positive or there's no sign in front of the 5x, I would do a plus 5x. And then my constant should go third, so the plus 6 should go last. And then is equal to 0. So between like these two steps, I was just kind of reordering the terms, and then notice like the negative went with the 7x squared, so I kept it with the negative 7x squared, and then the 5x was positive, so this became a plus 5x, and then the plus 6 of course just stayed plus 6. So standard form is it always has the x squared term first, and then the x term second, and then the constant third. If there's ever a time where like you're missing one of those terms, like we don't have an x, that's okay. You would always have to have an x squared, and you would just still start with the highest power and count down from there. Okay, so now we just need to find a, b, and c. So a is always the coefficient of x squared. So in this case, a is negative 7. And then we have to find b, which is always the coefficient of x. So since it's a plus 5x, b would be 5. And then we need to find c, the constant term, which is that plus 6 at the end. So c is positive 6. And then notice I didn't write like a equals negative 7x squared. It's just a, b, and c are just numbers. That's it. They don't involve the x's at all. Okay. So a is negative 7, b is 5, c is 6, and then we can move on to example 2. Find the discriminant of each equation and determine how many solutions the equation will have. So the discriminant, that formula was up here. So it's b squared minus 4ac. And then before I can use that formula, I have to kind of identify what a, b, and c are, and then put them into the equation. So b squared minus 4 times a times c, and then in the first equation, the 0 equals negative 3x squared plus 5x minus 6. A is always the number in front of x squared. I'm going to backtrack a little bit. I would always just double check to make sure that the equation is in standard form first, because sometimes the terms can be reordered, and it can kind of make you mess up like a and b or c. So to double check to see if it's in standard form, everything should be on one side, so we have a 0 over here, so that's good. And then x squared should be first, x should be second, and then the constant should be third. And I'm just going to go through and check each equation really quick. So 0 on one side of the equation, even though it's on the opposite side as the first problem, it's just by itself, so that's good. And then x squared is first, then x, then the constant, and then over here, x squared, x, and then the constant was 0 on the other side. So they're all in standard form, so we don't need to do any reordering there. We can just go through and find a, b, and c. So a is always the number in front of x squared. I think I'm just going to go ahead and rewrite the standard form formula up here so we can refer back to it. So a is always the coefficient of x squared. So in this problem, a would be 3. B is always the coefficient of x. So in this case, b would be positive 5 since it's a plus 5x. And then c is always the constant term. So c would be a negative 6. So I'm going to take those and put them into the discriminant formula. So b squared minus 4ac. So 5 will go in for b, and then 3 will go in for a, and then negative 6 will go in for c. So it would be 5 squared minus 4 times 3 times negative 6. So let's set up one more time. 5 went in for b, so it became 5 squared minus 4 times a, which was 3, times c, which was 6. And then now we'll simplify each part until we get like kind of one final answer. So 5 squared is 25. And then this next part, I like to think of the minus 4 as a negative 4 and count that in with my negatives. So what I mean by that is I'm going to count up how many negatives I have. I have 1, 2 negatives, the negative 4 and the negative 6. If you have an even amount of negatives, then when you multiply those two numbers, if you have an even amount of negatives, when you multiply those numbers together, you will get a positive product. So I'm going to put a plus right there, and then now I'm not going to worry about the signs. So even amount of negatives, like 2 negatives or 4 negatives multiplied together, you get a positive product, which is like kind of the answer when you're multiplying. If you have an odd amount of negatives, like 1 or 3 or 5, then you would have a negative product. So I counted the negatives. I have an even amount, 2, so it's going to be positive. And then now I can multiply 4 times 3 is 12, times 6 is 72. So plus 72. And when I count the negatives ahead of time, I don't have to worry about my negatives when I'm multiplying, which is kind of nice. And then from there, I can go ahead and add 25 plus 72, which is 97. And then when I'm working with the discriminant, I don't care so much what the actual like number is, like the 97. I care more about whether it's positive, 0, or negative. So the instructions say find the discriminant and determine how many solutions the equation will have. So I found the discriminant, it was 97, and then I can go up to this table up here. 97 is a positive number, so that means that this equation would have 2 real solutions. So that's what's going to go in the bottom box. 2 real solutions. And if you want, you can just leave yourself a note that that's because this was positive. So any positive number from the discriminant b squared minus 4ac means that there's going to be 2 real solutions. Okay, and then for the second equation, we're going to just kind of repeat the same process. So we find a, b, and c. A is the coefficient of x squared, so a is going to be 4. B is the coefficient of x, so b is going to be negative 12. And then c is the constant, so it's going to be 9 in this case. And then I'm just going to copy over my discriminant formula. And then we'll go ahead and start putting each number in. So negative 12, I'm going to put that in parentheses. Since b is being squared, I have to square the whole thing, like all of negative 12. And then minus 4 times a, which is also 4, and then times c, which is 9. And then if I square negative 12, it's negative 12 times negative 12, which would be positive 144. And then I'm just going to count my negatives. I only have 1 this time, so that means I'm going to have a negative product, so I'll just bring down the negative or the minus. And then I can multiply 4 times 4 is 16, times 9 is 144. So minus 144, and then 144 minus 144 is 0. So we found our discriminant. This time it was 0. So then I go back up to this table about what each outcome of the discriminant means. Because I got 0, that means I have 1 real solution. So down here we'll just write 1 real solution. We don't know what it is, but that's not really the point of the problem. The point of the problem is just to decide how many there are. And then the next one, 0 equals 5x squared minus 7x plus 4. So we'll find a, b, and c. A is coefficient of x squared, so in this case it would be 5. B is the coefficient of x, so in this case negative 7. And then c is the constant, so it would be 4 for this one. So we have our b squared minus 4ac. And then b is negative 7. Again, if it's either way, you can put it in parentheses, but especially if it's negative, we want to use parentheses to remind you to square the negative also. So negative 7 squared, and then minus 4 times a, which is 5 for this problem, and then times c, which is 4 for this one. So b squared becomes negative 7 squared minus 4 times a, which is 5, times c, which is 4. And then now we can simplify. So negative 7 squared means negative 7 times negative 7, which is positive 49. And then I'm going to count my negatives. This one I just have the 1 out in front, so that means if I just have 1, that's an odd amount. So I would have I'd have a negative product. So I'm going to bring down that negative. And then now I can just multiply. I don't have to worry about the negatives. So 4 times 5 is 20, and then 20 times 4 is 80. So 49 minus 80 is negative 31. So we found our discriminant, it was negative 31. Again, that's not the answer, sorry, it's not the solution to the problem. It's not what like x would make this equation work. It's just the discriminant, which tells us how many solutions there will be. So this was a negative number. So if we go up to this table, whenever there's a negative discriminant, it means there's no real solutions. And I kind of talked about this before, but whenever there's a negative as the discriminant, that means that there's a negative in the radical. And when there's a negative in the radical, it means there's no real solutions. Okay, so for the first equation, we got a positive discriminant. 2 means 2 real solutions. The second one was the discriminant was equal to 0 exactly, and that means there's 1 real solution. And then the third equation, we got a negative discriminant, which means there's no real solutions. Okay, so example 3, solve each equation using the quadratic formula. They're all three going to be kind of like similar problems, I guess. We just kind of need to practice a few different versions. So, 3a is 0 equals 3x squared plus 5x minus 6. So we want to go through, figure out what a, b, and c are, because we're going to put them in the quadratic formula, and then I just have the quadratic formula there to make it a little bit easier to see like kind of what we're putting in which spot. So I'm going to copy down the standard form formula again. So ax squared plus bx plus c is equal to 0, or the 0 can be like kind of in the front, like 0 equals all that. It means the same thing. So a is the coefficient of x squared, b is the coefficient of x, and c is the constant. So in this problem, a is the coefficient of x squared, b is the coefficient of x, and then c is the constant. So I'm going to put 3 in for every like spot where there's an a in the formula, because the lead coefficient is 3. And then b is 5, so that's going to go in for both of the b's. And then c is negative 6, so that'll go in for the c. So we'll set up our fraction, and then it starts off with negative b. So negative is a part of the formula, and then b would go here, which b is 5. And then plus or minus the square root of b squared. So whatever b is going to go right there, and it's going to be squared. B is 5, and then minus 4 times a. So a would go right here. A is 3, and then times c would go next right here, and c is negative 6. And then all over 2 times a, so 2, and then a would go right there. And again, a is 3 for this problem. And then I recommend starting with the like inside the radical to simplify. So it'd be negative 5, and then plus or minus. And then we're going to square the 5 first. So 5 squared is 5 times 5, so that's 25. And then I'm going to count my negatives. I have 1, 2 negatives. So 2 negatives is an even amount, so this is going to be a plus, or a positive product. And then now I can just multiply the numbers together. So 4 times 3 is 12, and times 6 is 72. So plus 72. And then over 2 times 3, which is 6. And then now I can add together what's inside the radical. So negative 5 plus or minus the square root of 25 plus 72 is 97. And then that's over 6. And then if you have a radical that you can simplify, you want to. We don't in this case. 97 doesn't have any perfect square factors. So sometimes it is like totally kind of expected and perfectly fine just to leave this as your final answer. So the way that we would write that is x is equal to negative 5 plus or minus the square root of 97 over 6. And then in certain cases, you'll be asked to like change it into decimal form to get an approximation. So if that's ever the case, you definitely want to use a calculator for it to find the square root of 97. And then I'm going to do or write that step kind of down here. So it'll be tucked under just so we have both versions. So the way I'm going to do that is I'm going to pull up a calculator and find the square root of 97, and then I'm going to replace the square root of 97 with it. Okay, so I have my calculator up, and this is just the Google calculator. I just need to find the square root of 97 and get that as a decimal form so I can get kind of like a decimal version of my answer. So to get the radical on this calculator, it's the fourth row and it's the third button over, that little kind of like, it's a radical, but it kind of looks like a funky check mark. So we'll click that and then we'll type in 97 and it gives us that decimal. We're just going to round it to 2 decimal places. So if I want to round to 2 decimal places, you can see it says like 0.848. If I want to go to 2 decimal places, I have to look at the third number, so that 8 in the third spot, and that 8 would round that 4 up to a 5. So I'm going to shorten that to about 9.85. And I'm going to continue that work down here just because I was kind of running low on space. So it'll be -5, or I'm going to include my x. And one thing we do in math, when we approximate or we get like a decimal that we have to round, we change our like equal signs, like kind of squiggly signs, and that means approximately. So instead of exactly the square root of 97, it's about 9.85. So -5 and then plus or minus 9.85 over 6. And then from there, if I have my radical gone, I do have to separate this into 2 different equations. So one that has like a plus 9.85 and one that has a minus 9.85. So I'll do that right here. So x is approximately -5. And then, hold on, I'm trying to figure out the best way to organize this just because I'm a little bit out of room. So x is approximately -5. And then plus 9.85 over 6. And then I'm going to do the second equation down below it, and we'll just kind of simplify as we go to the right. So the second equation, x is approximately -5, and then instead of plus 9.85, it'll be minus 9.85 over 6. And then I'm going to simplify this one first. So we can actually do this all in one step on the calculator, or not in one step necessarily, but kind of, yeah, I don't know how else to say it. So we'll say all in one step. So -5, I'm going to type in this like subtraction symbol to get the negative. So -5, and then plus 9.85. Oops. There we go. Sorry, the buttons are small. So -5 plus 9.85. I'm going to click enter to get that number. And so it's 4.85, and then I'm going to divide that number by 6, by the number in the denominator. So it's about 0.8, and I'm going to round this to 2 decimal places as well, 0.81. So that 8 that's in the third spot, it's going to round that 0 up to a 1. So one answer is approximately 0.081, and then we'll kind of repeat that same process, but with the second equation that we have. So the second equation, -5 minus 9.85. So -5 and then minus 9.85. I keep hitting that 8 again. So -5 minus 9.85 is -14.85. And then I'm going to take that and divide it by the 6 in the denominator. So divided by 6 is -2.475, but I'm just going to keep with the 2 decimal places, so -2, and then point. The 5 that's in the third spot would round the 7 up to an 8. So any like number 5 or above would round the previous number up 1. So about -2.48. Okay, so I'm going to go back to just having like the full screen up there. I'm not going to use like, I guess, get the decimal version of all the answers, but just know like some problems will require you to do that, so this is kind of the process that you would need to follow to get it into a decimal answer. But in a lot of cases, an answer just like this is all that's expected. Okay, so B, 4x squared minus 12x plus 9 is equal to 0. And you may have noticed in the previous example, but A, B, and C, all these equations are the same equations that we worked with up here. So if you ever notice that that's the case, you can kind of use the work that we did for the discriminant to kind of shortcut yourself into simplifying the like radical for like the full quadratic formula. So what I mean by that is like the first equation, like example 3a that we did, the discriminant was 97, and that's what we got the inside of our radical to simplify to. So if you notice that, you can use that. I'm not going to use that for this video just because I feel like it's helpful as we're getting started to have like as many examples as possible. Okay, so 4x squared minus 12x plus 9, we need a, b, and c. A is the coefficient of x squared, so that would be 4. So that'll go here and here. And then b is the coefficient of x, that's negative 12 since it's a minus 12x, so that'll go here and here. And then c is the constant, so since there's a plus 9 there, c would be a positive 9, so that would go here. So set up the fraction, and then it's negative b. So negative, and then b would go right here. So b is negative 12. So it'll be a double negative. That part's kind of funky. So the first negative is in the formula, and then the second negative comes from b. And then plus or minus the square root of b squared. So b would go right there, and then we got to square it. So b is negative 12. So negative 12 squared minus 4 times a, which on this one, a was 4, times c, which was 9. And then all over 2 times a, so 2 times 4. And then we'll mostly simplify the inside the radical first. I am going to simplify this double negative here, so when you see a double negative like that, it turns positive, so that would become a positive 12. And then plus or minus the inside of the radical, so if I simplify negative 12 squared, that means negative 12 times negative 12, which is positive 144. And then I'm going to count my negatives over here in the minus 4ac part. So I just have this one negative, so my product is going to be negative, so I'll put the negative over there, or the minus. And then 4 times 4 is 36 times 9 is 144. Oh wait, sorry. I said 4 times 4 is 36. That's definitely not right. 4 times 4 is 16, and then times 9 is 144. And then all over 2a, we can go ahead and multiply those two together. 2, so 2 times 4 is 8. And then now we can keep simplifying the inside of the radical. I'm going to shorten this line a little bit. So I have 12 plus or minus the square root of 144 minus 144 is 0. So I have a 0 inside the radical over 8. And then 0, you can take the square root of it. It's technically a perfect square, because you can square root 0 and just get 0. So this would become 12, and then plus or minus the square root of 0 is just 0, because 0 squared is 0, over 8. I don't know what happened to the bottom part of my 8, but so 12 plus or minus 0 over 8. And then usually when we have something that's no longer in a radical, we would create two different equations, one for the plus and one for the minus version, but plus and minus 0 is still, it's not changing the value at all. If I were to do 12 plus 0, that's 12, and 12 minus 0 is also 12, so I don't have to do two different equations here. I can just kind of cut out that 0. So I can just simplify down to 12 over 8, and again, that's because if I do 12 plus 0, that's still 12, and 12 minus 0 is still 12 as well. So we have 12/8, and then we just want to make sure that our final answer is as reduced as possible. So we want to think if there's any common factors. So 12 and 8 are both divisible by 4. So if I divide 12 by 4, I get 3, and 8 divided by 4, I get 2. So my final answer would be x equals 3 halves, or 3 over 2. Okay, for example 3C, this would be a good one to pause the video and see if you can do one on your own. If you want an extra example, of course, let's kind of continue through the video, but this would be a good one to test yourself. So C is 0 equals 5x squared minus 7x plus 4. We want to go through and figure out what A, B, and C are. So A is the coefficient of x squared, so A is 5. B is the coefficient of x, so B is negative 7. And then C is the constant, so C is 4. So 5 for A is going to go here and here, and then B is negative 7, that'll go here and here, and then C is 4, that'll go in there. So the formula starts off with negative B. So B is negative 7, so it'll be another double negative. So negative, -7. The first negative is from the formula. The second one is from what b is. And then plus or minus the square root of b squared. So -7 squared minus 4 times a, so times 5, times c, so times 4. And then all over 2 times a, so 2 times 5. And then we'll just kind of we'll simplify the double negative and the radical first. So -7 turns to +7. And then plus or minus the square root of, this is -7 squared. So -7 times -7 would be a +49. And then I'm going to count my negatives. I just have this one negative, so my product will be negative. And then 4 times 5 is 20, times 4 is 80, over 2 times 5, so 2 times 5 would be 10 in the denominator. And then now I can subtract the inside of the radical, so I'm just going to copy over the 7 first, so it'd be equal to 7, and then plus or minus the square root of 49 minus 80 is -31 over 10. And then when we talked about the discriminant, we said if we had a negative number inside the radical, it means there's no real solution, and that's because we can't take the square root of a negative number and get a real number out. So once you simplify the inside of the radical, if you end up with a negative inside, you would stop and say no real solution. Okay, so I'm going to zoom out and look at these kind of as a whole. So for like 3a, we had a positive number inside of our radical. Once we simplified it, that means our discriminant was positive, and we ended up with 2 real solutions. Even though they're kind of funky with the decimals, they were still real numbers. And then for b, we ended up with a 0 inside of our radical, so we had a discriminant of 0, and we ended up with 1 real solution, just 3 halves. And then for c, we ended up with a negative number inside of our radical, so it means we have no real solution.